The answer is maybe. Maybe we can burn everything or anything that we want, provided we reach the necessary temperature, then we have the necessary ingredients or the catalyst at that point, and if they are unstable enough. Now, what do I mean by those things? So in today's class we are going to try to understand fire a little more. We see fire every day, right? We see three things happening more or less. Objects become something else. We burn something, it becomes something else. And the next thing that we see is there is some heat and some light. What really happens? Let's dig deep, okay? So the first picture we see is nothing but wood burning. But then we need to try to understand all the bits and pieces of what's going on here. So to understand that, everything we see on this earth is mostly made of 118 elements which are in the periodic table. They are the base elements, so some form of those or any combination of those is everything that we see. And if some nuclear reaction happens, we might invent new elements, but as of now we have 118 in our periodic table, okay? So now what did I mean by that? If we see of any element, we go to the atom and then we try to understand the atomic structure. This is how it looks like. It's called Bohr's model. The only two or three simple things to understand are, at the center of every atom there are two things. It's called a nucleus, and in the nucleus there are neutrons and there are protons. Protons are positively charged, neutrons are neutral. The most interesting element is electrons. They are surrounding the neutrons and the protons, and they are in the form of a cloud. And neutrons are, as I discussed already, they are neutral, but electrons and protons, they are opposite charges, so they should cancel each other, okay? So now the next concept we'll try to understand is bonds. So what is a bond? Bond is when two different atoms, they come together, they share or they give each other exchange electrons, and the end goal is to become more stable. Why do they want to be more stable? Because now let's take a look at this picture. These are called energy levels. This is nothing but concentric circles which are surrounding the nucleus. They can have maximum number of electrons by the energy level. So in the lowest it's 2, then 8, it stays 8, okay? So this is the most stable. Every atom wants to reach this stage. So as for example, if we see the oxygen, right? Oxygen is in our atmosphere. It has 6 electrons here, 1, 2, 3, 4, 5, 6. Hydrogen also in our atmosphere, it has 1 electron outside, because that's their atomic number, right? So what happens is these two hydrogens share 1 electron each with the oxygen. That becomes H2O, our water, right? So this happens all the time, provided the catalysts are there, either temperature or pressure or availability, it can be anything. But the bond, the only purpose of explaining the bond is that they always try to reach a more stable stage and the lowest energy stage, okay? So now let's dig into fire. So in fire, what happens, as we discussed, wood is made of some elements which are present in the periodic table. So in case of wood, it has mostly carbon, hydrogen and some cellulose maybe, but mostly carbon and hydrogen. Okay, so what happens is, as we heat them up, so we start a fire, all the atoms get a lot of energy, and then what happens, this bonding starts to take place. Oxygen is abundant in the atmosphere, so the carbon mixes with the oxygen, becomes CO2, carbon dioxide goes into the atmosphere, then the hydrogen mixes with oxygen again, it becomes H2O, water vapor, it starts to go up. Why does the flame go up? Because of gravity. It becomes hot, then it generates low pressure, so all the high pressure air pushes the flame upwards. Then the question of next two things that are the outcomes, right? Heat and light. So first of all, the basic idea of heat is, once we give them more energy, the atoms starts to move around, right? They start to move. So what happens, these atoms are hot, they start to heat up or pass energy to the air molecules which are surrounding. They get heated, they pass to the next air, and we might feel some of that. The other thing is, the air gets hot around, it goes up because of the pressure difference. Cool air comes in, it again becomes hot. It's a circle. Okay, so now the last piece is very interesting, heat radiations, which is the most important form of heat transfer, because from sun it's not heating all the air because there is no air in space. So from sun we are getting heat in the form of heat radiations, right? What are radiation? That's a complex subject, we will discuss that sometime later. But now in this picture, see, this is a spectrum. Okay, so what does it mean is, from any kind of radiation has many wavelengths in that. Okay, and the only visible information that we see is the visible light, which is just a tiny piece of the wavelength spectrum. But then if we go little to the right, there is infrared, which are heat waves, microwaves, again they have heat. So these are all radiations that are generated by vibrating electrons. Why? Because when we heat, the electrons get heated, they jump to some next energy level, then they find some new partner, they form a bond, they come to low energy, they release energy. That energy becomes a wave and it starts to propagate in air or in space. And so just to show you what a wave is when the particles move at same point but the wave moves forward. If we see any football field or a cricket stadium, what happens is all the audience or the people who are watching some game, they stand up and then they sit down at the same place. But then once they do it in a sequence, the wave starts to move forward. That's how the wave moves, right? And then here this wave is a very small wavelength, and this longer one is a longer wavelength, right? So different waves. So basically what is happening is, in any kind of radiation there are many wavelengths. We just see the visible light, but there are also heat waves, then ultraviolet waves. So they are all different because their wavelengths are different. Okay, so we discussed. So now to summarize, in fire what happens is bonds are broken, new bonds are formed, energy goes up, energy goes down. When energy goes down, it gets released in the form of radiations, and radiations can be of any kind. There is a very thin slice which is visible light, but there are also many heat waves. Okay, so I think this gives a basic idea on fire. I hope you enjoyed it. If you liked the video, please subscribe to the channel, please press the bell icon, and hope to see you again pretty soon. Thanks.